Z alpha over 2. Remember that 1 minus alpha is equal to 99%. Why is it 99%? Because it's a given. The given is construct 99%. So 1 minus alpha equals to 99%, or simply 1 minus alpha is equal to 0.99. So solve for alpha, that will be 1 minus 0.99, so alpha is equal to 0.01. Okay, so to determine the alpha over 2, that will be z 0.01, that's your alpha, divided by 2. So you do have z, what is 0.01 divided by 2? That is 0.005. Okay, so 0.005. So how do you determine that 0.005? There are two ways. Okay, there are two ways. The first one is using the table. Okay, this one, the confidence level table. So 0.005. So Z alpha 0.1 divided by 2, that will be 0.005. So look, Z 0.005. So this one. So meaning your Z 0.005 is equal to 2.575. Okay, 2.575. So that is your Z 0.005. Your Z 0.005, that is your Z alpha over 2. Okay, Z alpha over 2. Okay, so that is 2.575. Now, we can now solve for margin of error by substituting it. So this one, and then this one. So you do have 2.575 multiplied by 46.5 over the square root of 30. So using a calculator, so you do have 2.575 times 46.5 divided by the square root of 30. So that would be 21.86. 21.86. So we can now determine the interval. So the interval will be mu is greater than sample mean minus the margin of error, but less than sample mean plus the margin of error. So mu, the population, okay, the population mean is greater than, what is your sample mean? Sample mean is 174.3 minus the margin of error, which is 21.86, but less than 174.3 plus 21.86. So mu, or pertaining to the population mean is greater than, so 174.3 minus 21.86, so that will be 152.44, but less than 174.3 plus 21.86, that will be 196.16. So therefore, the 99% confidence interval, okay, the 99% confidence interval of the population mean is between 152.44 to 196.16. It's between 152.44 to 196.16. That's it. So that's example number 1. Example number 2. A company that manufactures electronic calculators uses a certain type of plastic. An alternative plastic material is introduced in the market and the manager of the company is thinking of shifting to this material. He will decide to shift if the mean breaking strength of the new material is greater than 155. It is known that the breaking strengths of the new plastic material follow the normal distribution. So it's normally distributed and have a standard deviation of 10 psi, pounds per square inch. 6 examples of the new plastic materials were randomly selected and their breaking strengths were determined. The data obtained were 156, so these are the data. 156, so these are the data. 154, 168, 157, 160, and 158. So these are the given data. Construct, so we need to construct and interpret a 98% confidence interval. Okay? Construct and interpret a 98% confidence interval. Okay? So first, we need to come up with a 98% confidence interval. So to solve for the interval, it ranges to mu is greater than, so these are the interval. Mu is greater than sample mean minus the margin of error, but less than sample mean plus the margin of error. So this is the interval. But the problem is, there's no value of margin of error and sample mean. So we need to solve for the sample mean. So first, solve for sample mean. So sample mean is equal to, the only given are the data. Just get the summation and then divided by 6. Since 6, according to the problem, is a sample. So you do have 156 plus 154 plus 168 plus 157 plus 160 plus 158 divided by 6. So that will be your sample mean. So you get your calculator and then you add 156 plus 154 plus 168 plus 157 plus 160 plus 158 divided by 6. So you do have 158.83. So that is your sample. Okay, next, margin of error. So we have Z alpha over 2 multiplied by the standard deviation of the population divided by the square root of n. So what is your Z alpha over 2? So that is 98%. So to solve for alpha, 1 minus 0.98, which is equal to 1 minus 0.98. So that will be 0.02. So Z alpha over 2, that will be Z alpha is 0.02 divided by 2. So that will be Z is 0.02 divided by 2. So you do have Z.01. So Z.01, this one is your alpha over 2. So 0.01 is your alpha over 2. So how do we get the value of this one? Yung Z alpha over 2. Your alpha over 2 is 0.01. How do you get 0.01? Okay, how do you get 0.01? How do you get this? To get this, alpha is equal to 1 minus 0.98. Where do you get 0.98? In your 98%. Okay, in your 98%, so that will be 0.98. So your alpha is 0.02. So therefore, just substitute it. Z alpha over 2 is the same as Z 0.02 divided by 2, which is the same as Z 0.01. Now, to determine this value, yung z.01, okay, use the table. Don't worry, the table is given in the exam. So, look for z.01. So, z.01, z.01. So, the value of z.01 is 2.33. So, 2.33. Now, we can now determine the margin of error by substituting it. So, 2.33 multiplied by the standard deviation, which is, what is the standard deviation according to the problem? The standard deviation is what? The standard deviation is, according to the problem, the standard deviation is 10. Okay, so we have 10 divided by the square root of n, which is, your n is the sample. According to the problem, that is 6. 6 samples. So, 6. So, using the calculator, you can now compute. So, 2.33 times 10 divided by the square root of 6. So, that would be 9.51. Okay? 9.51. So, to determine the interval, so mu is greater than sample minus the margin of error, but less than sample plus the margin of error. So mu is greater than, what is your sample? 158.83 minus 9.51, but less than 158.83 plus 9.51. So mu is greater than 158.83 minus 9.51. So that would be 149.32, but less than 1.58.83 plus 9.51. So that would be 168.34. So that is the interval. So this is the interval. Okay? So therefore, so the interpretation is that, therefore, triangular dots, 98%, okay, 98% of the confidence interval for the true mean breaking strength of the new plastic material is between your range, your interval, 149.32 and 168.35. Okay? 149.32 and 168.34. That's it.